Hey there guys, welcome to our next chapter. Still me here, Andrew Maximoff, and right now we're gonna do something really awesome. We're gonna make a very elaborate shader for like your usual rock prop asset. And yeah, it's gonna be very rich on features, so let's just jump in. And this is like the first chapter that we're gonna have that is actually going to be very, very useful. At least it's supposed to be like for actual features, because most of our previous chapters were just theory, if you think about it. Well, mostly. It gave you some practical tips and tricks too, for sure, but this is purely practical, so I hope you enjoy it. What we're gonna do right now is, as you can see, we'll be using a usual material setup. It'll be opaque, nothing custom, no custom lighting and shit. Yeah, so what we're gonna do first is here we have our three textures for diffuse, spec, and normal. And now we probably want to sort out our UVs. And in order to do that, let's just grab our UV texture coordinate node here. But you know what? We won't plug it in here right away, because I'm gonna show you a little neat trick on how you can sort of optimize your work here. You see here I'm grabbing a component mask where you can sort of separate the channels of the incoming nodes, and we're just gonna plug this into UVs. And then we're gonna plug it into the texture coordinate, and then we're gonna plug this stuff where it belongs. And why we wanna do that is because, let me just grab a sphere. Okay, why do we want to do that is because right now we're going to be messing with our UV inputs a lot, and you really don't want to be constantly inputting in the new node, each node that we're going to be building up at the end here into the three UV input slots here. So what you can do, you create a component mask and then you just work with stuff here. For example, if we want to tile this stuff, we just go ahead and create a multiply node. And then we just go ahead and go for a constant. And for example, we want to just tile it twice. And then when we plug everything in, we just plug it into here. And that's it. You see, I didn't have to go through actually manually inputting it 3 times. And the sweetest part is that since the UV coordinate is actually just a 2 component vector, the mask component node doesn't do anything. Just upon parsing of the compiler, it just gets discarded. So it's just like a little minor trick for you guys to help you speed up your work. And right now we just have like your regular asset. So for example, if we go to our level, let's create night lighting just to be different for once. And now I have a rock asset over here, which is pretty huge. We can hopefully scale it down a bit. Okay, and now let's just assign our material. And we should have something, just for like preview purposes. Well, yeah, there you go. This is like our rock asset. But now I'm gonna show you some cool tricks that you can do with UVs. And the first one will be to keep your textile density consistent across multiple instances of the object that you're gonna make. For example, if I grab this and I clone it right here, and then I scale it, you see that the pixel size becomes like very obviously different. And that's a problem when you want to, have some heavy reuse in some assets. For example, you want to make like a cliff sort of structure and you want just to create a bunch of those rocks and just sort of, stick them into each other and blah, blah, blah. It would be a problem for sure. But the way you can alleviate that is you can actually make the texture tile according to your object radius, which is kind of cool and actually very, very straightforward. So if I go to more material, right here, what we can do is we can go to object radius. And there we go. This is just a node that gives us the radius of our object. So all we have to do now is just multiply our UVs by it, And you know, we also should probably multiply the object radius by a certain number just to make sure that our resolution at this point, our UVs stay pretty much the same. And like through some experimentation, I found that something around, let's say 0.42 would do okay for us. So let's multiply those. And I think we can ditch the 2 at this point and just stick this stuff in, plug this stuff in. And yeah, there you go. And yeah, I'm sorry, I'm gonna scale the window back to my capture frame. I hope that you guys saw everything. But now going back to here, you see that something changed. This actually became, the texture here became more tiled. And this is very accurate because you can see that as I tile this object now, the texture, basically the UVs sort of, well, as I scale the object now, the UVs sort of tile with it. And that means that no matter how big it gets, you get a constant textile density, which is very neat because it allows for a lot of reuse. And it's actually, as you can see, very, very easily done. Another thing we can do with UVs that is actually very cool is the world space offset of our UVs, which means that as we move our objects around the scene, the UVs offset as well. So for like the very repetitive assets and modules that get placed right by each other, they don't really have the same texture mapping, not even like in terms of tiling and scale, but even in general sense, just where they're mapped, which is very neat and once again very easy to do. So what we'll need our object world position node, and since this thing actually just grabs like the center of our object and gives us the coordinate of this point, it is a 3-component vector because we have our x, y, and z, but we only want 2 because our texture coordinates is a 2-component vector. In order to do that, we just grab our component mask and we go with RNG. Technically, we can choose any combination of vectors that we want, but RNG is basically x and y because our levels are usually laid out in the kind of space, which is just the XY space, and they're not really that height oriented, if you know what I mean. So we usually move our objects more in the XY space. That's why we're going with it. And once again, you probably want some sort of a number to multiply this thing by, just to make sure that they match our current mapping as much as possible. And once again, I did some tests for you guys. So the number that works for that kind of stuff is 00115, I think. And now what we do, since we want to offset our UVs and not really tile it more like the way we do here, we use an add node. Because otherwise when you multiply the transformations are just sort of too big. And I see that I plugged it in and nothing changed, which is a good sign, which means that the number is probably correct. But now let me just get this out of the way so you can see our assets over here. And now let's go into unlit because it seems a bit easier to comprehend. So now when I move this around, you can see that the UVs actually move with the object. So there you have it. You can have like your single rock asset, and you can be sure that no matter how much you tile it, no matter how much you populate the scene with it and scale it and whatever, you're gonna have your constant texture resolution for 1, and for 2, you can always be sure that your objects won't look exactly the same even if they're standing like right in front of each other, which is a very cool thing. And yeah, right now we're gonna go further and do something else. Hey, according to my plan, we're gonna do some height map based blending, which is sort of a common thing, but I thought I'd walk you through it, guys, anyway, and then show you some additional tricks with it on top of the basic, if you want. So yeah, for the UVs, we just want to put them aside. Sorry, let me scale down my window. We just want to put them aside. And we want to create a new comment where we'll just name this thing UV. and that's it. You know, it can happily rest wherever and not really bother us. Okay, so now for the height map based blending, we'll probably need another texture, you know, to blend this stuff with. So I'm just gonna go ahead and drag in the texture for moss that we're gonna be using today. So we have our normal and we have our diffuse. And we should probably create the UVs for that as well, because we are very likely to be tiling it quite a bunch. And you know what, technically we could probably reuse some stuff from here. I don't know if it will work, but let's try. Let's just grab what we had from our object radius. Let's not offset it. And let's just tile it like 5 times more than we tile our rock texture. And then let's just plug it in. And I don't know, let's see if it even works. Well, yeah, that should look more or less okay, I hope, and it should remain consistent as we scale our objects. So yeah, let's keep it at that for now, but we'll see if we'll have some problems with it in the future. But now, at this point, what we're going to do is we're going to go and work on our height map based blending. And I mean, the base of everything is our linear, linear interpolate. My bad. I just go full lerp right away. We have our linear interpolate here, and we need our mask, our height map. And I actually have my height map in the alpha channel of my normal maps. So right now we can actually blend those two. And I mean, in the height map, you usually have your darks being sort of the lows of your height map, which means that they are going to remain. Basically, what you saw me do here is actually plug the texture sample of our usual like rock normal map into the B slot. That's because we want the rocks. We want the moss to be in the crevices of our texture, so that's why it goes in the A, because in the height map, the blacks represent the recesses, the crevices. And I mean, it's kind of confusing. You don't even need to know that, to be honest, because all you can do is just test it. You can just plug stuff in, see if it works. If it doesn't, well, whatever, just change the order that you plug your nodes in, and that's it. So yeah, don't get too hung up on that stuff. It's just my weird obsession of trying to make sense of things all the time. So yeah, as I plug it in, you can see that we have some moss in our crevices, and well, let's do the same for normal maps. And ta-da! And you know what? Let's grab our mask component node here and plug it in for our UVs, just in case we are going to end up modifying our moss UVs a bit more. But now I think what we will want to do is we'll want to play with a height map and just work on the proper map, because right now it's not really what you want probably. But no, we're just going to do some stuff. So let's grab our normal map and let's, I don't know, let's for example add stuff. So here we go, our add node, and we can just grab a constant, for example, like 0.5. We'll just plug it in there. And you see, now we have to change our node over here for the mask, which also could be kind of redundant in a way. So let's just go here, name this height map. And it's just a component mask where the only component is R, which basically is just the one channel that we're using. So now we can plug this stuff into our height map mask, which doesn't really do anything. And yeah, you see our moss became like significantly more sort of relevant in here, but you see that we got some weird color artifacting, and that's because our texture has probably gone out of the boundaries of 0 to 1 brightness range, which is generally not good. So what you want to have is a constant clamp node in here. So yeah, you can see me plugging in the constant clamp, and there you go, it's gone. But now you can, you know, play with your offset, and you can see how it affects stuff. So yeah, I'm just changing some values to showing you how the moss sort of appears and disappears. And in order to make it a bit more fun, since we already tried that, let's grab a sine node and a time node. And since we're constant clamping our stuff around here, I mean, we shouldn't be getting any artifacting, but now if I plug in my real-time preview, you can see what happens, how sort of the moss just pops in and out, you know, through the height map that we provide, which makes it look, I don't know, kind of fun. At least, you know, this little kind of trick for you guys. Now, since we probably have spent too much time on it already, let's just rush through the usual stuff. You know what? Let's convert this one to parameter and just name it like, I don't know, height map push or something, since we're pushing our height map. You know, well, I hope that makes sense. Anyway, let's delete our sine node and time node. It was fun, but yeah, we have to move on. So for now, since, you know, vertex-based blending has been used a lot and most of you guys probably know how it's done, first, we're gonna do directional blending, which is kind of cool. I mean, we'll add our vertex painting later, but you can probably find a lot of tutorials on that online. But for our directional blending, let's go and do something that we've actually done before, so it wouldn't be that unusual for you guys. Here's our usual, you know, 3-component vector, and you probably recognize that already, where I'm just sort of specifying the local normal, and then I'm going to grab our transform tool, and I'm going to transform it from tangent to world space, and then I'm going to grab a dot product. And all it's going to do, oh yeah, and then we're probably going to go and grab our constant clamp here, and if we preview, you can see that all it does, it just takes the direction that we specified. Well, basically, the thing is, like, this one that goes here into A is just the local normal. But if we want to, you know, play around with it a bit more and specify a different direction, for example, we can go with this. We can just go with the Y positive value, and then when we plug it in, that's a bit weird because here we have our, you know, tangent vector that we transform to world coordinates, so technically it should be world now, but I might be confusing something because it is actually working if you do it the other way around, so it's not really relevant to us at this point, but as you can see, we can just go with the positive Y value, and there you go. You can like sort of specify the direction that you want, but usually as it happens, we probably want to have it pointing upwards because for things like snow, it usually, you know, falls from the top. So just let it accumulate there. That's sort of the idea behind it, and this is what we're going to do right now. And I'm going to keep those vectors here just in case, since you guys will have access to these materials. You'll be able, you know, to play around with it if you want. But technically what we can do now, after we clamp this stuff, we can just multiply our height map by this value that we got per pixel, because now it's just every pixel that has a certain height, or a certain, actually not height, but just a local normal to the vector that we specified relationship is going to have that value, that white and black. So now let me just grab a multiply somewhere from here. And let me just plug them in together just to preview. I mean, our height map should look like this, which is pretty bright, but it's actually, oh yeah, that's because we pushed it too far. So let's just try something like 0.25. So here's our height map, for example. Now we preview it, and we should get something like this, which looks kind of nice. So let's plug it in there, stop previewing node. And yeah, there is this one thing. Let me just do something real quick. Let me go into here, get one minus node, and just invert the height map value that we have now. So now we have it right. And the thing is, because of all the height map as being like from 0 to 1, but then us, you know, switching up where does the the rock go and where does the moss go into different channels and stuff like that, it actually gets a bit confusing on the thing, because we want the white to be for the moss, but the white in our case is actually for the rock, because technically we're showing off the rock through the moss, because the moss is supposed to be at the bottom. So the easiest way to alleviate that is just to invert this thing here, just put a 1- in our height map. But technically I guess you could revert the height map itself, invert in Photoshop. But this is just something, you know, to think about beforehand. But anyway, so now if we actually apply this material and go here and take a look at our lovely rocks, if we grab one, like the smallest one that we have here, and now we just go ahead and rotate it, see what happens? The rock, the moss projects automatically on top of it. And I mean, I could probably go back to our material and just add a little bit more punch to our moss, like 0.5 for example, or even 0.7, because it's only projected on top. Yeah, this should be more obvious, but as you can see, as I rotate it, it automatically projects on all the surfaces. And the cool thing is that it's actually per pixel, so it takes into account your normal map as well, which means that it would be projected like somewhere here. As you can see, you still get some moss because you get sort of the slight angle, but the normal maps are taken into account as well. So it's like, it's not really geometrically just on the top of your object. It's basically wherever the normals are pointing in the specified direction, which is kind of cool. And just out of curiosity, let's scale it and see how it holds up. Well, yeah, you can see that the moss tiles with the rock texture, and this is pretty much all we need. But that's really useful. You can use it for all kinds of things like beat moss or snow or sand, any kind of environment footprint, because this is something that sort of affects the believability of your environments a lot more. So yeah, anyway, now let me drag my shader window back up here for you guys. So I promised to do the vertex thing. Let's just grab this, and the vertex color thing. Let's just grab our vertex colors. Let's grab our height map as well. And vertex colors are a bit tricky because generally you sort of want to just multiply it, but multiplying doesn't cut it because you just darken your height map, but you also need to brighten it because it's sort of an average value. So for example, if we drag it here once again and just take a look at this, if we multiply it, we just get it all black, which means we're just getting everything moss, but we can't really multiply it like by more than 1 because vertex colors that we're painting are just from 0 to 1. So in order to sort of fight that, what you do is you grab your height map and you subtract. I'm just looking for an add node to copy. And yeah, just one thing. And click on the screen for a constant 1 vector. Just press 1 and click on the screen and stuff like that. But for me, it's easier to just go this way. So what I want to do is I want to subtract 1 from our height map, and then what I'll be doing, I'll be adding our vertex color. We'll grab the Rad Channel, multiplied by, where do we have our multiply? By 2. So that way our vertex colors will control sort of the whole range, because now basically when vertex colors are black, it means that we aren't adding anything. It remains black. So it's like completely moss. But if vertex colors are white, then it means 2. So, and since our height map can be like -1 tops, well, the lowest value that we can get is -1. So when we add 2 to it, we will get our 1 like completely white color, which technically means that we'll be getting just rocks, which is all we need. So yeah. setup. And I'm sorry, I realized that oh yeah, constant clamp, obviously, my bad. You can see that whenever you get those weird color artifacts, just try constant clamp, see if it works, and that's it. But yeah, now at this point, just let me grab the Rad channel because it would make more sense to just use one channel for this stuff. But if you see me talking like about what value we get, where it's really pretty confusing, and you don't really need to, you know, like know them by heart and do all the math in your head and stuff like that. I mean, the environments like this, the Unreal Material Editor provides you so much flexibility that you can just plug stuff in, see how it works, and if something wrong, just change the numbers, change the channels or whatever, just constantly experiment, and actually use that a lot sometimes to just plug stuff wherever and see, you know, how it goes. And generally, you can get what you want with experimentation. You don't really need to keep all that stuff in your head. Okay, so now let's apply it and go to our assets, which are completely mossy at this point, but let me grab our Vertex painter, and it might get a bit. How big is my brush? There you go, it's getting bigger. Now I can actually paint, and it's all black. I should probably get more strength. There you go. Now you can see that, yeah, it's actually working. And now we can probably half the strength, but it, or even like 0.33 and 256. Now you can see that I sort of 0.2. Okay. I can erase out our moss according to our height map. And once again, this is actually very, very common these days. I mean, to be honest, not many games use it like all the time because, well, just to go with your usual diffuse textures is still way cheaper. But it's something that you definitely want to know. Yeah, I just wanted to cover it for you guys. So anyway, at this point, what we can do is, well, we can blend the two together if you like. But that would be fairly straightforward. For example, here we had our directional blending. And let me scale back my window for you guys. Sorry, I keep forgetting about that. And here we have our Vertex Colors, Vertex Painting, let's call it that. And in order to just make them work together, blend the Vertex Painting and Directional Blending together, which is actually way more tricky than you might anticipate. But anyway, I mean, like the general logic is that this is white because we inverted in a way. So technically, like all the original info is reverted. And this is white as well because the default Vertex colors are white. But our moss should be black, which means that we can just darken this thing since it's generally white by just multiplying it. So we grab a multiply node. Where do we have it? Here, and we just multiply them together. And that should cut it. Actually, that is pretty surprising, but here's a trick. Let me show it to you. Okay, so I'm just gonna drag it out of the way. So yeah, you see our directional blending started appearing, but I'm just gonna drag this window out of the way. So you guys will see that as soon as I accept our changes, ta-da, all the painting that we did, the Vertex painting is gone. And you can see as I scroll around here that there are black dots and white dots. So technically I'm painting like in all channels with all kinds of values, but there is nothing there. And that is because info is not getting passed down from the Vertex shader to the pixel shader, because technically there are like two separate entities that get processed consecutively. You get your Vertex shader going, then the stuff gets sort of pushed down to the pixel shader. and you have a limited amount of slots of info that you can, sort of send from vertex to pixel. And you have your UVs there, and you have your vertex colors, for example, and you can actually just put everything you want there. It's like, well, there are like some minor restrictions, but basically you get the idea. So the UDK shader system probably just has a lot of stuff going on there, and we sort of add to it in a way. So that creates a problem. And the way we can actually fix this, this is crazy. What we're going to do right now, we're going to grab a reflection vector, and then we're going to subtract. And what we're going to subtract is we're going to just subtract the reflection vector from itself. So we'd get a 0. And now we need an add node. Let's just grab an add node right now. And we just add it to wherever we want. Let's say here. So now technically our shader uses the reflection vector even though it does nothing. And what we need this for is now when we go into properties of our shader, we have an option here, a checkbox. We can choose the camera vector to be per pixel instead of per vertex. And as soon as we click this stuff, let's go back. There you go. We have our vertex colors back. And now we can actually paint away and paint back in, and you can see that our projected side, our projected part stays there, and we can add some more if we want. And this is really, really neat. But as you can see, the idea behind this whole trick is that probably the reflection vector is one of those things that just occupying space in that sort of the channels that we want to send our info from the vertex to pixel shader. So when we set it to per pixel, it might just get calculated in the pixel shader, so it doesn't get sent through this channel, and we can have our vertex colors in place of the reflection vector. So it's kind of hard to judge how much it adds to calculations, but since we're not really using reflections right now, I don't know, if we still calculate the reflection vector per pixel, it is kind of sad if we have to calculate like for every pixel that we're going to render. But in like a proper production, you could probably get your programmer, to try and fix this stuff, and hopefully it will work. But yeah, here's like your general setup. And one other thing, which is actually pretty important, is well, something that I would set up for myself is you probably want some control over the projected mass as well. So for example, here what I'm doing, I'm just grabbing a vertex color, and I'll be multiplying this final output that goes into the invert node. Why am I doing that is because right now we'll be able to actually just grab our green. Well, we can see that I'm actually using, well, I can just grab like a green channel separately, but now I can paint in and paint out the projected mass that we have. And you probably want that control because sometimes projection doesn't give you the exact results that you want, so you can dedicate 2 channels, which with Rad Channel being painting for everything, as you can see me do now. And green is just for the top part, and you can see now I've just removed the green, but we still have the red, so it shows. So we can just like paint them both away, removing and sort of adjusting the projected mass that we have through the green channel. So this is basically, yeah, only even more interesting, if that's impossible. But anyway, it's actually a very, very simple thing to do, but I know that a lot of people have been asking me how I did, for example, the projected mass in my scenes, and the trick is here. Here we have our vectors, and instead of one of them, we're just going to use a vector that we can adjust in real time from UDK. I mean, we could have just specified the coordinate through here, but it's kind of boring. So let's just try and grab, surprise, surprise, the wind direction and speed. That's it. I mean, UDK actually uses this stuff for wind if you want to like play around with foliage and everything, but it doesn't mean that we can't reuse this stuff for something else. So we want to grab our component mask and do an RGB pass on it, because the alpha also holds the intensity of the wind, and sometimes we just don't really want that. So let me just plug it in. I'm not really sure instead of which of those nodes I have to plug it. So yeah, in case it's wrong, we can just do some minor experimenting. But at this point, I'm just moving it away, closing the Vertex painting tool. Then I go, let me just drag this over so you guys could see it. I'm going to my, and yeah, I should probably just make it full screen. Should have made it a long time ago. Anyway, I'm going here, and there's supposed to be the wind actor, and the point source usually doesn't work. So what you do is you grab and you just drag it into your scene. See me? Let me scale it up a bit for you. Let's say it's just the icon, so you guys can have a better look. But that's it. Now I grab my rotator and I rotate this stuff. And yeah, as you can see, when I rotate, the projection shifts, and we've got some colors going on in here. So let me just grab the Vertex Color tool and then just remove everything that we have, and probably go into Mesh Asset and just paint it all white. And finally removed all the vertex colors that I had, so now I just have to grab my wind actor and we can clearly see how the projection works. And that's it. You see, it's fairly simple. We just replaced one vector with another. And well, yeah, the biggest trick here is just to, I don't know, just to come to a realization that this wind thing is not wind exclusive, and you can just appropriate it to whatever needs you have. And voila. And now, for example, if we go to our vertex painting, and let me just set it to 0.25, you can still paint stuff. And I actually painted my mesh asset, so you can see that there's like the moss appears in other props as well. But there you go. You can paint it wherever you like. I hope you guys like coming up with that stuff. But